Thank you, Isha. Hello, everyone. Thank you for joining. Today, we will explore how we can leverage large language models to ask questions to a knowledge graph using just natural language. The goal is to let domain experts be able to tap into the power of connected data, even if they don't have the technical skills that are required to write Cypher queries, for example. And we want to leverage large language models because they are showing this ability to do language understanding, do some sort of reasoning, and they are able to generate context that's useful for our task. And they are getting better and better over time. So before diving in how we believe is the best way to tackle the problem, let's see how these question answering systems are built today. So the most widespread approach these days is RAG, Retrieval Augmented Generation. The idea behind RAG is that not every question can be answered by LLMs alone. If I ask who I have to call in my company to get a new printer, for example, the LLM cannot give me an answer because they don't know about my company. In other words, the data that is required to answer my question was not in their training set. What we can do, what I could do is to give, for example, along with my question, I can give information like my org chart or the list of responsibilities in my company. In this case, that's another story because the LLM are very good on identify the piece of information needed to answer my question if I provide this type of contextual information. So the idea behind RAG is that there is the extra component, is called the retriever here, and it can be implemented in many different ways. But what it does in a nutshell is to perform some sort of semantic search, considering your query, your question, against all the documents that you have, all your knowledge base. And the retriever is able then to identify the semantically most relevant documents, and you then can use those documents as a context along with the question to be sent to the LLM. And the LLM can use this information to ground the answer on. Okay, this system works, but it has some limitation. First of all, RAG relies heavily on the retrieval. If the retrieval phase fail to extract the relevant documents, we're given complete information, the LLM cannot help with the answer. Imagine that you have a challenging question. A user can start asking this type of questions. And this type of question usually require many different pieces of critical information. And those pieces may be spread among multiple documents and maybe even not related, these documents between each other. So since the retriever can grab so much content, there is some chance that some of this piece of critical information will be missed. So when you provide an incomplete, contextual information to the LLM, bad thing happens because the LLM will try anyway to give you an answer. It will try its best, even if you have to make up content. So it can give a wrong answer because you provide incomplete context. And it is difficult to talk. This problem is difficult to tackle because the LLM try to give you a confident answer even if they are missing some critical information. We call this hallucination. And this is not the only problem. I think it is the RAG approach is definitely not something an expert would do. So what will an expert do then? Imagine that you have to answer a question and you have a knowledge graph for doing that. What you will do? The first thing you will do is to go to the schema to try to make sense of this knowledge graph. And if the question is about people, the answer has some reference to that person node that you have found into the schema. Now imagine that we are in a law enforcement setting and someone asks you to get the list of all the red Camaros that were spotted in a certain area in a certain point in time. What you will do? Well, the first thing you will do is to go to the schema and try to find node like car or vehicle. And when you get that, you will try to find in the schema anything that can actually spot a vehicle. And you may find an NPR camera, for example, those cameras that can read your plate number. In that case, you know that you are almost there. So you need something that connects these two ideas, these two concepts. And then you may find in the schema a relationship, or you may find a camera event. In that case, you get it, right? Because you have camera, NPR camera generating a camera event. The camera event is capturing a vehicle. The vehicle maybe is owned by someone, a person. You got it. You have a traversal. Once you have your traversal, what you will do is to start applying constraints. You're not interested on every single camera in the world, but you want to just know the ones that lay into the area of interest. Same thing for the events, just want to know what happens in that time frame. Another constraint. The car has to be red, the model has to be Camaro, you got it. You have constraint traversals, and you can use these constraint traversals as a building block to write a query using a formal language like Cypher. And you can execute this query formally against your knowledge graph. And what you get from there is actually exactly the information, the result you're after. And there is zero chance to hallucinate in this stage. Okay, so then when you got your results, your nodes and relationship, you decide how to present them. You can present it like a graph or a chart or using a map, a table, whatever you say it fits, depending the question that they give you. So that's what an expert will do roughly. So let's see this approach on an LLM perspective. Let's try to see if we can automate this process. So what we really need is, first of all, we need the ability to reason, because we have to translate a question into some sort of plan. Then we need the ability to perform some sort of semantic search, as RAG does, but not on the whole data, but just on our metadata, on our schema. We can see this problem from another angle. Imagine that this could be described as a translation problem towards a foreign language. In this case, Cypher will give you the grammar, but the schema is going to give you the vocabulary, the terms that you will need to build your foreign language. And then it's a matter of translating using LLMs. We also think that this kind of an expert-based approach is also implying some sort of paradigm shift, because we are moving away from the concept of how to generate the answer, which is what RAG does, towards something like more how to ask the question properly. And we think that this does a lot of the difference. Now, before moving on and show you a demonstration of how we implement those ideas, let me stress a bit this expert approach concept. We basically, I'm going to show you the demonstration using GraphArray, which is our graph analytic platform. And we built this platform, this software, for analysts. So for people that has to, answer critical questions using knowledge graph every single day. We have built features for them, as you can imagine. We have built the ability for them to describe a conceptual schema on top of the schemaless, and for J. We have the ability to annotate with free text, basically anything, classes, property, anything. So they don't have to rely just on the name of a relationship, for example, to know what this relationship is doing. In general, we build features for them. And what you will see is that we leverage all those features in our solution because the LLM is trying to mimic their behavior. So the LLM is going to face the same type of problem for which we already have proposed some solution to our user. And if you think about that, this is kind of true in general, because if you already have a product and you want to transition towards a Gen AI solution, if your solution is mimic what the behavior of a user, you won't end up with a backlog filled by features that compete between features that improve the user experience or features that improve the LLM answer or the quality of the answer, for example. And we believe that this is something important from a product perspective, especially if you are on a transition stage. Okay, so now let me show you a live demonstration. So this is Hume. This is basically the visualization tool of Hume that the analysts use to navigate the graph. And what we have added is this user interface, so we can use to interact with our system. So This is a law enforcement knowledge graph. You see the schema here, and I will pretend today to be an investigator, and I want to start my investigation. So I can ask question here. I will start to something very basic. I'm asking to have a crime node so I can start my investigation. You see, what happens is that when I hit the button, my question is sent to the system along with the schema description. And we can use this, the system will use this information to implement on a multi-agent approach what I have described so far. And the results you get are basically what you see here. We have a node, and we have a couple of textual results. We have the reasoning and a summary. So the reasoning is useful for two purposes. First of all, it will give you a user an understanding of what's happening under the hood. So basically, the idea is that we don't show just nodes and relationship on the canvas, but we give also, an explanation or a plan of what's happening. This is useful if you have a complex schema, for example. Then you may traverse the same thing with different relationship in a slightly different way. And since we are using, natural language, there can be some ambiguity. So knowing the plan will help your user to fix any misunderstanding down here, typing a few words and clarify what has to be clarified. It's also useful for the machine, because the model is forced to generate all these tokens that you see here before generating the answer. This gives the model the so-called time to think. So the model won't rush into some obvious but perhaps wrong answer straight away. So again, this is something that it's useful for both the machine and the people. And we have the summary here. So we can have a look at what is this crime. So we can see here is a criminal trespass. We know the date. It's under investigation. And we see from the report that there is a vehicle, black vehicle involved with a partial plate number. So what I can do is to select my crime and ask this question down here. Like I'm searching if there are any NPR camera within nearby. Okay, you see the system, it gave me the results, and it also switched into a map view, because it is smart enough to understand that it's the best way to present this specific type of information. And that's true, not only because you see that the NPR camera down here is pretty close to the crime node, but they also position it in a strategic position, so we can get some interesting leads for our investigation. So let me select the camera this time, and I will ask if there were some vehicle that were spotted the day of the incidents that are compatible with the description. Okay. So what we got here is a schema, a graph expansion of all the nodes that matched my question. All the vehicles that you see here are potential candidates for further investigation. And if I look on the summary, there is not much of extra information here. We got basically what you see to the canvas. So let me try to do something different. Let me select just the crime and the camera. And I want to try to ask the same question, but in a different way. Here, I'm not saying just give me notes, all right? I'm saying, look, I'm an investigator, and I'm working on the selected crime, and where I am, here we go. And I need this type of answer. So I'm not saying what I want. I'm just referring to what I have selected, okay? But most importantly, I'm saying here, like, I'm basically asking for insight. I'm asking if among these results there is something that is more likely to be involved compared to others. So as you can see from the result, there is not much of difference, right? We have basically the same results. But so this means that this type of changing the question doesn't affect the text to Cypher agent, for example. But probably it will have done something on the summary step. Let's see. Yes, we have here the same summary, but we have an extra step here. And if you read through, it says that the vehicle AB1, I think this one, was detected twice within a short time frame. That's true. and which might indicate a higher likelihood for involvement of incidents compared to other vehicles. So we're basically saying, let me select back, we are basically saying that this vehicle is actually more interesting from an investigation perspective. So let me try just one last thing here. So I'm not touching anything. I'm basically asking the same question, but I just nudge a bit the system, say, look, sometimes those vehicles are owned by previous offender. So let's see how the system answered this question. Here we go. So you see now that it expands further, and you found that amongst all these vehicles, just one is owned by this guy. And if we look at the summary, we say that the black Chevrolet with a compatible plate was detected, okay, and its owner is shown on it, 20-year-old or whatever, and they say that he has, okay, that's an important part, who has an history of previous offenses, specifically has committed crimes including battery and criminal trespass. And this is important because criminal trespass is exactly what we are investigating. So with a few questions, you see that we have now a vehicle that is strongly tied to the location, the owner of the vehicle, which has a criminal history that is compatible. So we definitely have enough information to say that this person here can be actually a good candidate for the suspect. It's potentially a suspect, and we can start the investigation. We can further investigate on this person. Okay, so this example, we are basically showing that how we can use this system in a sort of a realistic setting, and also how we can push a bit the summarization step, and how we can leverage this step to actually give us more insight considering the data. And this is important, especially if you have many data on your canvas. Okay, so I think that I can spend the rest of the time to show you how we implement this exactly. So let me switch to Orchestra. So this is Orchestra. This is our Orchestrator tool. It is basically a low-code tool that we use to basically draw any type of workflow. And this is the whole workflow that we use to implement everything you see so far, in anything you saw so far. So it can seem complicated, but it is not actually. So up here, we have an initialization step. We basically write down all the prompts, the template for the prompts, and I will show you those briefly. And down here we have the error handling stage. So basically, since we have statistical systems that can provide any type of response, we have to deal with errors. This is something that will happen. Okay, so what happens is that we capture the error when they happen, and we do some post-processing for the error, and we also give them another try if it is the case. So we can fix it something and rerun and give it another shot. Okay, so this is the main flow. So from here we start. So in Orchestra, all the components that you see here basically take one message in, which you can see like a sort of a JSON object, and then they do some processing and give a JSON out, another message. So it's basically a stream of messages, and you can see the flow here. So the first thing that happens is that when I hit my button, I basically call this webhook, and so the flow starts. So the first thing that we do, let me zoom in a bit. The first thing that we do is to do the intent detection. So what we are trying to do here is to okay, this is the let me go here on the okay. So this is the output of the previous stage. So we will see the results in here. So basically, what we do here is to try to understand the type of output that the user expects, considering the question. Like in the example, we want to be a map when it's the case, a chart, a graph, depending on the type of question. Okay, so we implement this stage, this agent, basically through a sort of a classification task. So we support graph, table, chart, and maps in our view. So we say that we can choose between those. We explain a little bit better what they are. We give some examples down here, and then we ask the question. And this is the type of results that we have. So we are interested on this string, basically, and then we have a reason output. So the reason is not something that we do actually surface, but it's still something useful because you can use this reason field in case of misclassification. So if for some reason the system is wrong, it won't give you just graph, but we tell you why it thinks that it's graph. Okay, so you can use this type of information basically to write down an extra examples here, for example, and this can be used to classify or specify better the boundary, for example. Okay, this is sort of a basic or a standard way to deal with the classification problem. So I will move on quickly. So the next thing that we do is to convert the schema that I showed you at the beginning to something that the LLM can handle. Let me show you the schema tool. Okay, this is the way that we can define schema in EM. You see we have classes with property, relation, same thing. If I go here on a vehicle, you see we have a description to the attribute color, and it is like a specification that the color code has to be this one. Like if we say black, we actually mean BLK, and that's important for the constraint part. Okay, so what we have to do, what we do in that step, is to take all this representation programmatically and convert it into a format that the LLM can handle. And I think I can show you here. Yes. For example, for the relationship, we use this type of format. You see, we have the source class, the end class, the relationship, and also property with the type, if there are. So we have a list of textual representation of the relationship. Same thing for nodes. We use this format here, in which you have a class and the relation. A class, the properties with their type. Okay, so what we do next is to fetch the annotation that I showed you earlier, and every single annotation that can be put already into the graph, into the schema as a description, and then we collect all this information to build a prompt. And I can show you the prompt. I will show you the template because I think it's easier to follow. Here we go. So this is the template. This is a Jinja 2 template. Okay, we have a macro at the beginning. This deals with the example. So if you provide an example, it will use yours, otherwise it will use some default example. So the prompt basically starts here. We say that it's a text to Cypher task, basically. We show the user question. We expand it with the actual question. Then we show the schema, and we use the format that I just showed you, right? So we have the nodes here, the relationship here expanded. Then, if the output format we identify in the previous step is graph or map, we give some requirements of how we want this graph to be extracted. If it is a table, we do basically the same thing. Then we show the examples. Then we show the annotation, every single annotation we have, as I showed you earlier. And then we show again the question. We repeat the question down here because this section here can be pretty large. Depending how large and how many property your schema has, this can be pretty large. So we don't want the question to be too far away from the response, 2 tokens away from the response to improve the quality. Yes, basically from the same reason, we repeat the requirement if it is the case, and then we specify the type of response that we have. So we basically are expecting a JSON response. The first and the order of these properties is important. So the first thing that we ask is the relationship, so a list of any relationship that I think may be useful to traverse. Then we have the reasoning, and the reasoning is what we surface, is what you saw basically in the visualization. And then we have the query. So the order is important because the query has to be consistent with the reasoning that the model has already generated, right? So basically, this reasoning is the so-called tensor thing that I mentioned earlier. All right. I think I can show you also an example of how it is expanded. So if you go here, this is how we expand the request for the last question we asked. We have the prompt here. You see, we have the question expanded, we have the schema with the format that I showed you, and so on and so forth. Then we have the requirements, the examples, the descriptions that is important, including the color format, and yes, and then we have the output format. This will basically produce this type of response. It is still a JSON with the relationship. Those are the relationships we want to traverse. The reasoning, that is what we have said. And finally, the query, the Cypher query. Okay, so the Cypher query gets extracted. Then we have a component that basically fits if there are minor problems with the syntax. We fix them here, and then we execute the query. So this component can be used either in read-write mode or in read-only mode. So you don't have to be, to check if there is some write and if you don't want to write, for example. So that's pretty important. So what we do, depending on the type of the output, we basically convert the output to the format that the human canvas understands. We store the response, and then yes, we notify the plugin that I show you, the blue one, that basically the response is ready, so we can fetch the response. And specifically, if we have a graph result, which you see the graph or map, what we do as an extra step is to compute the summary, and then again we notify the viewer and say, okay, there is a summary ready. I think we have some minutes. I can show you also the summary down here. It's very simple, actually. Template for the summarization is like that. So we say, okay, the user asks this question. We decide to use this query to answer, and those are the results that we got. Please summarize it. That's it, basically. What we do as an extra step is to say, does this, the request contains also some kind of post-processing? If it's true, then please do it. Then we repeat the question again, because you may fetch a lot of records and this section can be pretty long. So we repeat the question, and then again, we do the same type of response. So the first thing is results analysis, true false. That's useful basically for us to understand if this section has triggered or not. Then the usual reasoning, and then the will not surface, and then the summary. Okay. So I think that's it. The key points that I want to recall is that, we basically show that sometimes RAG is not enough. And using this expert approach has some benefits. Even if we are still in a sort of research stage, we already understood that mimic the expert behavior is important because it's easy to maintain and to extend. If you have an issue, or if you want to implement something new, you have just to ask yourself, what would an expert do? And then try to add yet another agent that is fine-tuned to fix that specific problem as we saw before. Again, it makes to reuse existing features because they are going to face basically the same problems, and it's easy for the transition towards when you're doing some Gen AI transition. I think that's it. I don't know if there's some time for questions. I will take them. Okay, it says fix the Cypher. Okay, fix the Cypher is basically a component that basically analyzes the Cypher query using a DSL and a library. And basically, if there is some issues like the name of the property is written within a space, for example, or the relationships are generated on the opposite side. This happened because this language model doesn't care that much on the relationship direction. For these small issues, we can basically solve them straight away with this microservice. Okay. You mentioned again. Okay, Yum is our main tool. Is the graph analytic tool that we have built our graph with. It's used basically by law enforcement agency or governmental institution, this kind of thing. So we have this type of client. So this is the tool that we have built for them. And I don't know if there are any questions, because it's a product, so you have probably to speak with and see like if it is possible to find out like this is a tool that we install on-prem on our client. Okay, then if there are no more questions, I think there isn't. All right. If there are no more questions, I will thank you all for attention, and I appreciate the time you take it with me today, and enjoy the rest of the conference. Bye.